Okay, everybody, so this is a quick video covering, well, not going to be too quick, but we're going to cover the amino acids, why they're polar, why they're non-polar, and what's up with these charged ones. So basically we'll go through them, and I'm just going to go through amino acid by amino acid, show you why it's polar, show you why it's non-polar, talk about what it means, and give you some ways to identify it yourself. So let's zoom in here. We're going to start with these non-polars. Let me get a color that looks good on here. Alright, so we know that non-polar means there's no polarity, and we know that polarity comes from an unequal distribution of electrons, usually from something that is more electronegative. So we'll look at these. For instance, we have an OH, an OH, an OH, an NH, an NH. Alright, so those are moments of polarity. So let's hop back up here to the non-polars. These R groups. So yes, there's a plus and a minus in the amine and carboxyl, but those actually cancel out, and we won't factor those. So you can go through and basically count off everything. We're just going to be looking at the R groups. So let's go through every single one of these, mark the R groups off, and identify why it is nonpolar, also known as hydrophobic. So you're going to see these ones inside of in the interior of proteins, inside of the cytoplasmic membranes. You're going to see them in areas like that. So starting with glycine, there's just the hydrogen hooked to a carbon, and we know that there's no polarity there. So there's no partial negative, partial positive. It's nonpolar, therefore it's hydrophobic. So we're going to group some of these together. So all of the ones with carbon chains, where there's nothing but carbon chains, let me circle those ones. So, oops, nothing but carbon chains, nothing but carbon chains, nothing but carbon chains. Okay, so a carbon chain is hydrophobic, and a good way to conceptualize this is to think of a lipid and think of that fatty acid tail. It's nothing but a long line of carbons. So carbon chain is always going to be hydrophobic. So right off the bat, we have 1, 2, 3, 4 hydrophobic amino acids that just have carbon chains. So that's going to be really easy to visualize. Oh, geez, there's another one over here. 5. So these are going to be really easy to identify in the backbone of structures. So next, let's go to the aromatics. Now, so it gets a little tricky here because you see this NH bond. Now, that is polar. That's a moment of polarity. But these massive, this aromatic group is huge. It's so big that this little area of polarity really doesn't have an effect, which is why this is going to be nonpolar. Over here, we just have a very basic phenyl. And so that's, remember, this phenyl ring, those are little carbons right there. So that's nothing but carbon hydrogens. And we know that carbon hydrogens are hydrophobic. Alright, so what did we just say? How to look at nonpolar. Actually, for the example, let's go over to this video I made earlier. Let's go through here and look at this after talking about what we just talked about. So, you're shown this big strand, this polypeptide strand, and you want to know how it's going to work. So right off the bat, go through, find all the polar things. So here, boom, that's polar, polar, polar. So now we know we're left with all these non-polars. And we know how those are going to interact. They're going to want to find their way to the center of a protein that's in water. And that's because of the hydrophobic effect. Now, these other ones that we just marked out, that one, this one, and this one, those are polar. So let's go back to our amino acid table and talk about why those are polar and what that means. So we're going to look at this whole thing. So all of this is hydrophilic. Because remember, charge, that means there's polarity, and it's going to be hydrophilic. So let's go through the polar ones first, and then we'll go over to the charge. See how this red comes out on this blue. Nice. Okay. So once again, we're just going to look at the R groups because we know these cancel out. These cancel out. We'll look at the R groups, R group, R group. All right, so we got a lot of polarity going on. Right here, this is a very big moment of polarity. Okay? So that is obviously polar. It's going to be capable of hydrogen bonding. This is capable of hydrogen bonding, hydrogen bonding, hydrogen bonding, hydrogen bonding. And then it also has more polarity here. So when you look at this, it might be easy to confuse this with one of these. But you just have to remember that these massive aromatic groups right there is why that's not down here with the polars. So when it comes to polars, you really just want to look. One second, let me erase all this junk. When it comes to polars, or amino acids that are polar, just find these high moments of polarity. Whoops. And remember that polarity is just a very electronegative molecule hooked to other atoms that aren't as electronegative. So we have nitrogen, which is very electronegative, hooked to carbon and 2 hydrogens. It's going to create that polarity. Let's go over here to the charges. So where do these plus minus charges come from? Remember, first of all, this charge is in a pH of roughly 7.4, which is called physiological pH. So the reason we have this is because this group right here. So we have a plus, a minus, and then another minus. Plus, minus, minus. And the same goes with up here. This is also at roughly pH 7.4, which is physiological pH. And you have your plus, minus, but then we have a plus down here. Plus down there, so minus, plus. So all of these have an overall plus charge. And remember, these don't want to have plus charges. These don't want to have negative charges. So they're going to do things to balance that out. They might hydrogen bond. They might form some weird ionic bonds. They might form bonds with water. They might act as receptors. They're going to have some sort of function. So when you see these, just know how they're going to interact. These nonpolars, you're going to find them inside of globular proteins that are inside. If a protein is in a polar solution, these nonpolars are going to be inside. These polars are going to be outside. These are going to be outside because all of these are hydrophilic. These are hydrophobic. So hopefully this video kind of helps clear up the amino acids. Yeah, I feel like that covers most of what you guys will need to know with amino acids. If you want to go down a deeper rabbit hole or explore amino acids even more, there's, man, what could you guys look up? Look up isoelectric points and how they change, how the charge of amino acids change in different acidities. Yeah, and also remember, these are your 20, 23, or 20 essential amino acids. There's actually hundreds and thousands of amino acids. So there's a lot of amino acids out there, and we're just looking at the essential ones that life needs. These are the ones that life really needs to continue doing what it does, which I guess is living. So, alright, that's it for this video. Hopefully it helps some of you guys out. Take it easy.